All right, let's dive into this lesson on arc lengths and areas of sectors. So what's going on is, if you remember circles, let me find a circle. Right, circle. Uh, we've been measuring this in degrees. Say this is so 98 degrees. Well, that's just how open the angle is here. This is not the distance, the actual distance of this, right? Because we don't measure distance in degrees, we measure in things like inches and feet and stuff like that. So this does have an actual distance. You can measure in inches or feet or miles or whatever. And that's what arc length is. There's arc measure, that's degrees. There's arc and arc length. Arc length is the distance. And so we're going to today figure out how to do that. But if you're going to do that, you first have to remember how to get into radians, because you can't get arc length with just degrees. You have to use radians. And a quick recap of how to do that, pi radians is equal to 180 degrees, if you remember your unit circle. And so if you want to go from degrees to radians, you times by 180. Sorry, if you want to go from degrees to radians, you times by pi over 180. And so let's do a few quick conversions here. If I want this to be in radians, I times by pi over 180, which turns into 135 over 180 pi. And that fraction there does reduce. Let me look at that. I believe it's 3/4. I'm going to say it's 3/4 pi because I remember my unit circle. And that would be the exact value, but if you want the approximate value, you just need to times by the pi. So it's going to give you about, hold on, let me get my pi here, about 2.356 radians. Okay. And if you wanted to convert going to the other way, you just times by the reciprocal. So instead of pi over 180, you do 180 over pi, and you can get the degrees. The pi's are going to cancel. You got 2 times 180, which is 360, divided by 3, which is going to be 120 degrees. So 120 degrees. But yeah, mainly you're not going from radians to degrees on this. You're going from degrees to radians because things need to be in radians to get arc length. So I kind of had a quick recap. This is the formula for getting arc length. The arc length is equal to your degrees in radians times by your radius. And yeah, that's it. That's the whole thing. It's a fairly simple formula, but you just have to remember you need to have the correct kind of units in it. So your angle has to be in radians. So let's say I have this example here. I want to find the arc length if the radius is 5 centimeters and the central angle is 72. Remember, if you have a central angle in a circle, that's the same as the arc measure there. So that's 72. And you're trying to find the arc length. Well, you're going to convert it to radians. So you take 72 times by pi over 180. And then you'll be timesing that by the radius, which is 5 centimeters. So you can get 72 over 180. Do some simplifying of that. You got 2/5 pi times by 5, which is going to give me 2 pi, because 2 times 5 is 10, divided by 5 is 2. So that's the exact value, and the decimal approximation, just 2 times pi. So that's 6.283, etc. Oh, it says nearest thousandth, so I'll stop at 3 there. Centimeters. Ta-da! I can put centimeters on both. So that's how you get arc length. The other thing you need to be able to get is the area of a sector. So a sector is a piece of the circle. If you remember a long time ago, not too long ago, the area of a circle is pi r squared. So if you want the whole area, you figure out radius, do pi times r squared. Well, if you wanted half of that, then you just do pi r squared times by half. And if you wanted perhaps a fourth of it, you just do pi r squared times a fourth. Well, what this is all turning into is if you want any sort of portion of the circle, you just do that portion out of all the way around. Say you're in degrees, you just do however many degrees out of 360, and then you times by pi r squared. So you take pi r squared and times by what portion you're going around the circle. And if this is already if your angle is in radians already, you don't want to do out of 360. You want to do out of the number of radians, that's all the way around, which is 2 pi. Because remember, pi is 180, 2 pi is going to be all the way around. So this turns into your angle out of 2 pi times pi r squared, which that actually does simplify a little bit because the pi's cancel. And so your area, if it's in radians, is going to be pi over 2 times r squared. So you just do, and get a little formula looking like that. And that's what's here, these two written out here. This one, there should not be a pi here. I don't know why. Oh, no, sorry. There should be a pi because it's pi r squared. Sorry, I'm used to it being with the r squared part. Anyway, so you have your angle, figure out what portion it is out of 360, and then times by pi r squared, and you get the area of the sector. So let's go ahead and do one of those. We got example A, which is a similar setup we had before, but we're getting the area of the sector with a radius of 5 centimeters, and the central angle is 135. So I have my circle, central angle is going to be 135 here. Well, you need to figure out what portion that is of all the way around. So I do 135 out of 360. And again, times by pi r squared. Oh, I guess I should probably replace r with the actual radius, which is 5. And so now I got this, 135 out of 360 gives me 3/8. I got pi times 25. And times by 25 here. And you get 75/8 pi. So that's the exact value. And then you can get the approximate by actually timesing by pi, which is going to give you about 29.452. And since the radius was in centimeters, this is also in centimeters, but not just centimeters, it's an area, so it's going to be centimeters squared. So there we go. Voila, area of a sector. And so when you get to your actual assignment, is arcs and sectors, you're doing that. You should pay attention to what you're trying to get. Here you're trying to get arc length. Remember, arc length, cursive L, is equal to your angle times r. R is your radius, and the angle must be in radians. So for this one, the radius is 10. So I'm looking at times 10. And we got 44 here. We need to take 44 and times by pi over 180, which is going to give me, 44 divided by 180. Simplify a fraction. We got 11/45 pi. So this part is going to go here. And then you times them together, and you can simplify it. You got in terms of pi, that's the exact value in the decimal approximation. And it says to round to the nearest thousandth, so round to the third decimal place. It's pretty easy. When you get down to this section, this is actually easier because it's already in radians. So it tells you the angle in radians, and it tells you the radius. So remember, arc length is just your radians, angle in radians times r. So this turns into arc length is 11 pi over 45 times 10, which is, 11 times 10 divided by 45. Whoops. 11 times 10 divided by 45. And simplify, you got 22/9. 22/9 pi. And there's that part. And then we're going to do a area of a sector here.
Okay.
What was that? And so remember, your area of a sector is, the portion is out of the whole circle, which since this is in degrees, we're going to do 120 out of 360. And then you just times by pi r squared, which your r in this case is 10, so I'm going to put 10 in there. And that's my formula, 120 out of 360, which is a third. I'm going to times by 10 squared, and 10 squared is 100, so it turns into 100 thirds times pi, and then you can times that by pi. Sorry, exact terms, 100 thirds, thirds pi, and the decimal approximation just times it by pi, which is about 104.71. Oh, I'm going to round to the third decimal place, which gives me that. And this is in inches, so I'm going to do inches squared. But there you go. Couple quick formulas. You just have to figure out if your radians or degrees and calculate. Should be pretty quick. Good luck.